All right, so for this section in chapter 4, we're going to do with 4.6, the multiplication rule for independent events. All right, so the equation we're going to look at is for the general multiplication rule for independence is a probability of A and B is equal to the probability of A times the probability of B, okay? So with that, the next thing we're going to worry about too is the probability of at least 1 is equal to the probability of 1 minus probability of none. And we're going to go over these two examples in our notes today, so sit back and let's figure it out. All right, can we predict traffic jams and snow days? A local news station recently added a traffic jam calculator and a snow day calculator to their website. So the traffic jam calculator for the next week gave out that data right there. The first question wants to find the probability of Thursday traffic jam and interpret. Well, it already gives us the probability for Thursday. It's showing us this value right here. So we can simply say the probability for a Thursday traffic jam is 0.5. With that, for interpreting, it's a 50% chance that a traffic jam will happen on Thursday. All right, so probability of Friday traffic jam. Well, a Friday traffic jam, it gives us that probability of 0.7. And interpret that. Well, we have a 70% chance of a traffic jam on Friday. Are the events Thursday traffic jam and Friday traffic jam independent, and it wants us to explain? Well, yes. Knowing whether or not Thursday has a traffic jam will not change the probability of a traffic jam on Friday. They are independent of each other. So again, yes, knowing whether Thursday has a traffic jam will not change the probability of traffic jam on Friday. They're independent of each other. So moving on, number 4 here, probability of a Thursday traffic jam and Friday traffic jam. This is where it comes into our rule that we just came up with, okay? So again, probability of A and B is equal to the probability of A times the probability of B. So we simply have what value here? Probability of a Thursday traffic jam was 0.5, 0.5, multiplied by Friday traffic jam of 0.7, 0.7. And put the handy dandy calculator, she gets 0.35. All right, so now it says probability traffic jam every day of the week. Well, we're going to simply take every one of those data values for probability and multiply them together. So we should have Mondays of 0.4. We should have Tuesdays of 0.2. Wednesday of 0.3, Thursday is 0.5, and Friday is 0.7. Again, you put that in the handy dandy calculator, you should get 0.0084. Then I want you to find the probability of no traffic jams all week. Well, find the probability of all traffic jams. Find the probability of no traffic jams all week. We'll need to take the probability that's left from each one of these for each day. So in other words, to have no traffic jam on Monday, the probability is 0.6. The probability of no traffic jam on Tuesday is 0.8. So we're going to continue to do that for each day of the week because this is listed as a probability that there will be a traffic jam. So 1 minus this will give us the value of it not being a traffic jam. So again, you should have 0.6 times 0.8 for Tuesday. And then for Wednesday, 1 minus 0.3 is going to give us 0.7. For Thursday, 1 minus 0.5 is 0.5. And for Friday, 1 minus 0.7 is 0.3. If we multiply those all together, you should get 0.0504. All right. What is the complement of at least one traffic jam all week? Well, the complement, this is wanting the wording for it. So the complement of one traffic jam all week is no traffic jams all week. That's the complement, right? No traffic jams. Then it wants us to look at, find the probability at least one traffic jam this week. Well, this goes into that equation that we were looking at and our big ideas. Probability at least one is equal to 1 minus the probability of none. So again, probability of at least 1 is equal to the 1 minus the probability of none. Okay, so find the probability of at least one traffic jam this week. Well, we found the value of none, right? Because we just did that, no traffic jams all week. So if we do this, we simply take 1 minus a probability of no traffic jams, and that is equal to 1 minus 0.0504, which gives us 0.9496. And that is a probability of at least one traffic jam this week. Sounds like good old San Antonio traffic on I-35 in the morning. 95% chance, pretty much. So 94.96% chance of one traffic jam this week. All right. So now we're going to look at the snow day calculator for next week. All right. So what is the Thursday snow day? Well, Thursday again, we got 0.7. What does that mean? Well, there's a 7% chance of snow on Thursday. 7% chance of snow on Thursday. Probability of Friday is a snow day. Well, if we look at Friday, we got 0.6, 0.6. 60% chance of snow on Friday. Now it's asking for, are the events Thursday snow day and Friday snow day independent? No. Knowing that Thursday is a snow day would increase the chances of a snow day on Friday. Maybe a storm blew in on Thursday, so we don't know. Again, the weather is kind of dependent upon each other, right? So again, no. Knowing that Thursday is a snow day would increase the chance of a snow day on Friday. It's maybe a big storm hit on Thursdays. We don't know. That could play on one another, okay? Things could happen with weather that are not independent. They may be dependent upon each other. So the last one here says, find the probability of Thursday snow day and Friday snow day. Well, with this, if we want to find the probability of Thursday snow day and Friday snow day, could we just take 0.7 times 0.6, right? We should be able to. It's our rule? No. The reason we can't do that is we just answered it. We just said that they are not independent. They're dependent upon one another. So not independent. You cannot calculate. cannot calculate it. They're not independent, okay? All right, so if you learned a little bit something about dealing with the multiplication rule for independent events, and also the probability of at least one is equal to one minus probability of none. All right, guys, I'll see you next time.